Greetings, fellow explorers of innovation. I'm Ernis, your guide through the fascinating world where cutting-edge research meets real-life impact. Today, we're cracking open a paper that could revolutionize how we design analog circuits. Now, imagine you're an architect designing a magnificent city, but instead of buildings, you're crafting circuits that bring our digital world to life. Have you ever wondered why designing analog circuits feels like navigating a labyrinth? The paper we're diving into today is titled AnaFlow, Agent based workflow for reasoning-driven explainable and sample-efficient analog circuit sizing. These researchers from KU Leuven are tackling a monumental problem. How do we automate the incredibly complex and often error-prone process of analog circuit design? So, what's the big idea? The core message here is this: by using a team of AI agents powered by large language models, or LLMs, we can mimic the way expert designers think, making the process faster, more efficient, and, crucially, more understandable. It's like having a team of brilliant consultants available 24/7, each specializing in a different aspect of circuit design. Now, let's step into our memory palace, a sprawling campus dedicated to circuit design. The first building we encounter is the Analysis Center. The key here is that these agents don't just blindly optimize, they reason, they explain, and they learn from their mistakes. The paper has a few major sections. First, they introduce the problem and explain why it's such a headache. Then, they walk us through their AnaFlow framework. Next, they present their experimental results. And finally, they conclude with a summary of their contributions. Ready to dive in? First, let's set the stage. Analog circuits are the unsung heroes that bridge the gap between the digital realm and the real world. They're in everything from our smartphones to medical devices. But designing them is notoriously difficult. Unlike digital circuits, which can be largely automated, analog circuit design is still a very manual process. It's like trying to build a skyscraper with a hammer and chisel. The authors point out that traditional automation techniques, like optimization algorithms and even reinforcement learning, often fall short. They require tons of simulations, and they operate as black boxes, offering no insight into why they arrived at a particular solution. That's about as helpful as a GPS that gets you to your destination but can't explain the route. So, how does AnaFlow work its magic? Picture this: instead of one monolithic AI, we have a team of specialized LLM-based agents working together. Think of it as the Avengers. But for circuit design, each agent has a specific role. Let's stroll into our first room in the Analysis Center. The Circuit Explainer analyzes the circuit's structure, figuring out how all the components are connected. It's like a detective piecing together a crime scene. Ah, I see. This transistor is connected to that capacitor, which forms a crucial feedback loop. Next, we enter the Matching Finder. This agent identifies components that need to be precisely matched for optimal performance, like a differential pair. These two transistors must be identical twins for this circuit to work properly. Then, we have the DC Goal Setter. This agent determines the ideal operating conditions for each transistor, ensuring they're all working in the right regime. This transistor needs to be in saturation, and that one needs to be in the active region. Finally, the Initial Designer synthesizes all this information to generate a plausible initial set of component sizes. Based on everything I've learned, let's start with these values as a baseline. Now, let's move to the next building, DC Op Sizing. Before we commit to expensive simulations, AnaFlow enters a preparatory phase to establish a reasonable DC-biased solution. This is handled by a specialized iterative loop, intentionally constrained to a few cycles, around 5 to 10, to limit LLM calls and runtime. The objective here is not to reach perfect DC convergence, but rather to rapidly gather insights into the circuit's behavior. Okay, so now we've got our initial design, but how do we refine it? That's where the next stage comes in, an iterative loop of analysis and refinement. This loop involves two key agents, the DC Reviewer and the DC Sizer. The DC reviewer runs a quick simulation and checks whether each transistor is operating as expected. If not, it provides feedback, like a stern but helpful professor grading a student's work. Transistor X is in cutoff. We need to adjust its bias. Then, the DC sizer takes this feedback and figures out how to adjust the component sizes to fix the problem. Okay, let's increase the width of transistor X to bring it back into saturation. This loop continues until the design is reasonably well behaved from a DC perspective. It's like fine-tuning a complex machine, making sure all the parts are working together smoothly. Now, onto the third building, reasoning-only sizing. Once we've got a good DC operating point, it's time to optimize the circuit for performance. And here's where things get really interesting. AnaFlow enters a reasoning-only sizing phase. What does that mean? It means that the AI agents try to optimize the circuit using their knowledge of analog circuit theory, without relying on external optimization tools. Think of it as a virtuoso musician improvising a solo, relying on their deep understanding of music theory to create something beautiful. This phase also involves two key agents, the specs reviewer and the reasoning sizer. The specs reviewer runs a full simulation and evaluates the circuit's performance against the target specifications. The gain is too low. The phase margin is insufficient. Then, the reasoning sizer uses its knowledge to figure out how to adjust the component sizes to improve the performance. Increasing the length of these transistors should boost the gain, but it might also reduce the bandwidth. Let's try it and see. This loop continues for a while, with the agents iteratively refining the design based on their reasoning. Finally, we've arrived at our last building. Optimizer, equip sizing. If the reasoning-only approach hits a wall, AnaFlow can call in the big guns, external optimization tools. These tools use sophisticated algorithms to explore the design space and find the best possible solution. But even here, the AI agents play a crucial role. The advisor reviewer monitors the optimization process and provides advice on how to configure the optimization tools. The optimization is stagnating. We should try a different algorithm or increase the simulation budget. The equip sizer integrates the optimizer's suggestions into the design, ensuring that the final solution meets all the specifications. We found a design that meets all the requirements. Let's package it up and send it off. And here's the really cool part. Throughout this entire process, AnaFlow provides detailed explanations of the decisions being made. It's like having a transparent audit trail, showing exactly why each component was chosen and how it contributes to the overall performance. Now, you might be wondering, does all this actually work? According to the paper, the answer is a resounding yes. The researchers tested AnaFlow on 2 circuits and found that it could automatically size them with minimal input from the user. Not only that, but it achieved better sample efficiency than traditional optimization techniques. Fine, yeah, I guess. Look, the point is, this paper is a big deal. By combining the power of LLMs with a structured, agent-based workflow, AnaFlow represents a significant step towards truly automated analog circuit design. It has the potential to transform the way we design circuits, making it faster, more efficient, and more accessible. But perhaps the most exciting aspect of AnaFlow is its explainability. By providing transparent justifications for its design decisions, it empowers designers to understand the underlying trade-offs and learn from the AI's reasoning. So, what does this mean for the future? Well, it suggests that AI is not just about automating tasks, it's about augmenting human intelligence. By working together, humans and AI can achieve things that neither could accomplish alone. I'm your host, Ernis, and I hope you enjoyed this journey through the world of AnaFlow. Until next time, keep exploring, keep innovating, and keep asking questions.